Hey everyone, Sycra here, and in this series I'm going to be covering what I know about rendering light and shadow. And I'm going to cater this to people who are at the beginning levels, and maybe later on it will get more advanced. But if you are someone who is advanced, or maybe even intermediate, a lot of this information you probably already know, and I'm going to be presenting it in a way that is going to be leaving out certain parts in the beginning just because I want to make it easy to understand, and then as I go on later I will add, well, the exceptions to the rules and all that stuff. But in the beginning I'm going to keep it very simple. So the first thing I think that is important to understand is planes. And I don't mean the ones that fly in the sky. What I mean is flat, two-dimensional surface. So if you could imagine just like a sheet of paper, that is a plane. It's flat and it's two-dimensional. Now, you can have one plane. So here's a plane and it's sort of facing this direction. And I don't know if you can see that or not. And I'm just creating a cross so that you can sort of see that this plane is facing a certain direction. Now I can add another plane. So imagine if this was a piece of paper, then I can fold the paper and create another plane. And now this plane is facing this direction, right? So that is really important, is to understand about planes. So to begin with, I'm going to start with like a piece of paper almost that has been, and you can do this like with an actual piece of paper, but a piece of paper that's sort of been folded so that you have three planes, right? Here's the first plane, second plane, third plane. Now, in the beginning, I'm going to talk about light as if it all comes from one direction and all the lines are parallel. So, you know, okay, so for instance, you have different types of lights. You have like a lamp, right? So you have a table lamp. Now, the light coming from here, it's not going to be parallel, really. It's going to be coming out. It's coming from one direction, but it's sort of, you know, spreading out like that, right? We're not going to deal with this right now. We're going to deal with it as if the light was all coming from one direction. And this is kind of how sunlight works. And the reason is that, let's say you have the sun and you have the earth, and this isn't to scale, but there's a big difference, right? So even though the sun is spreading its light out in all directions, because the earth is so far away, by the time the light reaches it, it's almost going, and because it's so small in comparison to the sun, the lines are almost all parallel. So you get this kind of situation where the lines are all parallel. So let's assume there's a light source here. So I'm just going to describe the light source. I'll use like a circle, and then I'll just create parallel lines. So let's say there's a light source and light is shining. Now, what gets hit and how light is that going to be? So the thing with light is, if you have light coming from one direction, whatever is at a right angle to that light, so whatever is perpendicular, is going to get hit the most. Does that make sense? So like if the light's coming from this direction, right, and that you have a wall, then this wall is going to be hit much more than if you had a plane, let's say, going in that direction. And let me quickly explain why that is. So we have our wall. No, forget the wall first. First, let's put in our light. So we have our light particles. And of course, these are going to be much smaller than this, but for the sake of this demonstration. And let's just assume there's equal amount of space in between all these. I mean, it's pretty close. So I'm going to label it 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now let's say I have the wall, right? So let's do a wall. And then let's say I have another angle, another plane, and it's at that angle, right? And then let's say I have another plane, and it's at that angle. So this angle right here is perpendicular to the light, this one. And this one is at an angle, and this is at an angle. Now, why would this be lighter than this one or this one? Well, let's just count how many of these particles, because they're all spread out pretty evenly. How many hit each area? Well, this one gets hit 1, 2, 3, 4, 5 times, right? So let's say 5. This one gets hit 1, 2 times. 2. And this one only got hit by 1 particle. So as things are facing the light, there's more chance of them getting hit by light particles, meaning they're going to be brighter. So this would have like a brightness of 5, this would have 2, and this would have 1. So in drawing terms or painting, this might be that bright, and this might be still pretty bright, but not quite as much, and this would be more dull, right? Does that make sense? So it's all about how many light particles are hitting it, and the more light that's hitting it, the brighter it will appear. So going back to this then, you have light coming from this direction, right? So it's from here, and it's all coming down in that. So angles that are closer to being perpendicular are going to be lit up a lot more. So if we look at this angle, it's much more, it's not perpendicular. Perpendicular might be, it's coming from here, it might be like that angle. But it's close, right? It's close to being perpendicular. So this plane would get hit by a lot of light. Now this plane is sort of, it's not perpendicular, but you know, it's like at an angle like that. So it's going to get hit by some light, but less. So we can color that in. So it's much darker, right? Not much darker, but it's a bit darker. And then what about this? Well, if all the light's coming from this direction, and again, I'm not viewing this as like the spotlight, as if it's like that. I'm viewing it just as the light is coming from this direction. So it could almost be thought of more just like an arrow describing where the light's coming from, and not so much as like a lamp that we're shooting the light outwards. It's just, no, the light's coming from this direction. Maybe I could even just simplify it by making it an arrow in the future. But anyway, let's say the light's coming from this direction, then it's not really going to hit this plane at all. So this plane is going to be relatively dark. So now you have 3 planes, and you have one that's lit up very strongly, that's more close to being perpendicular to the light. and then you have one that's still getting hit but it's not as light, and then one that is in shadow. Now, these three planes are what are necessary to turn a form. You see, right now, the form here is turning, right? We get the sense of this happening, right? It's like a bent piece. And it's also easy to see this simply by looking at this shape, because we already, even from the drawing without the light, we can see the form is turning, right? But what if I just create like a swatch of these three values beside each other? So we have, it's just going to be squares of value. So we have the light, and beside it we'll have this tone, which would be the mid-tone. And then beside it, I'm going to have this shadow. Now, even with just this, it sort of feels like we're looking top down at a form that is actually turning, right? Even though it's just three values, you can feel like, oh, okay, this thing is sort of, you know, it starts here and then it kind of turns. Like if we looked at it from a side, it would look like that. And that's important because that is how to show form. So if you could imagine this shape being something more like this, you can almost start to see how this could be a nose shape, right? Like, oh right, you've got this side of the nose and then it turns over. So this is why it's really important to understand about planes, because then we can see this sort of does look like a nose already. We can understand what is going to be hit by the light, and therefore what is going to be the brightest, right? So in this case, we'll just go over it again. I know it might be repetitive, but the things that are the brightest are the things that are perpendicular to the light, to the direction of the light. So the things that are at 90-degree angles to the light. So if the light wasn't facing here, but it was facing here, like that, then this side would be lit up the most, and this, it would sort of just reverse. If the light was coming from this side, then you would get a situation where, okay, let's just do that then. Let's do it so the light's coming from this side now. Well, is this angle perpendicular to the light? No, right? Because it would be that would be perpendicular. So this is not perpendicular, so it's not going to be lit up as much as this, because this one is sort of perpendicular. This one's not. So let's make this sort of a mid-tone, because it's not getting hit by that much light. And then how about the top plane? Well, if the light's all coming from this direction, then that top plane isn't really going to get hit at all. So that's going to be in shadow. So you can just block that out as being in shadow. And how about this back plane? It's also going to be in shadow, right? Because the light's not hitting. There's no way in this scenario that the light's hitting that. So then you have a case where you have something that looks like this, where you have a midtone and then a shadow and a shadow. But is there any part of this in this this scenario that is going to be really bright? Well, actually there is, and it's right on the corner here between this edge and this shadow. Now, why is it that right on this edge you might get a higher highlight? Well, let's zoom in and look at what a corner is. So from far, a corner just looks like that, right? Or even, you know, any plane. So it could be that, could be that. Just here's the corner, here's the corner, here's the corner. And it just looks pretty straight. But if you think about, like, let's say you had a desk, and this was the corner, this was the edge of the desk, then yeah, that looks straight. But you can imagine if you zoomed in, way in, you would see that actually that's not exactly straight, right? You can't make something perfectly, like a perfect corner, right? Because as you zoom in, you're gonna see that it's sort of rounded, right? And by that I mean what appears to be rounded, just it means it's broken up into many planes, right? So if I zoom in even further to this area, it would look something like this. You would get many little planes making up that curve, then it goes down. So let's say the light is coming from this angle. It's coming from here, top right, and it's coming down. So is this angle here, is that perpendicular to the light? Well, no, it's not. So it's not going to be that bright. How about this angle? No. So neither this side nor this side are perpendicular to the light if the light is coming from here. But one of these angles, like let's say this one, actually is perpendicular to the light. So that little angle is going to be lit up, and then this one is going to be lit up a bit less, This is going to be a bit less, and then this one is going to be even less. So because you have that one little plane that is perpendicular to the light, that's why on the corner of things, the edge of things, you often get a highlight. And practically you might have seen this where you might have, let's say, an anime figure, and you might have noticed this sometimes where they have, let's say this is the shoulder, and also they do this with things like the nose, and you'll notice there's these little, sometimes, I mean it depends, there's like little point highlights, and they're on the edge of the shoulder, maybe they're touching the lip, they're touching the nose, and it's like, well, how do you know where to put that light, or you know, even why there needs to be a highlight there? And it's a case of, in this case it makes it look shiny, but the reason is that there is a plane that is perpendicular to the light here. Now it gets a bit more complicated because it's not just perpendicular to the light, but the light travels, hits the plane, and then goes into your eye, and if it's also bouncing back to your sight, then it's going to be here. But again, let's not deal with that just yet. Let's just think of it like a corner, and that's why you get those highlights.